Let's take a look at some composite functions and evaluating them at a specific number. Notice here we've got f of 4 plus g of 4. So there's two ways I can do this. I can simply evaluate f plus g, because this is really f of t plus g of t. So I can just write, there's my f, 4t plus 1, right, plus g of t, all right, which is 4t plus 3. And I can simplify, okay. 4t plus 4t is going to give me 8t. All right, plus 1 plus 3 is going to give me plus 4. So there's f of t plus g of t, and then they tell me to plug in 4. So I can simply plug in 4 here for this. So 8 times 4, whenever I see a t, I plug in a 4. That's an 8 plus another 4. 8 times 4 is 32 plus 4, or that will give me 36 is my final answer. Okay, I could also do it this way, right? I could find f of 4, and I just plug in a 4 there. 4 times 4 is 16 plus 1 is 17. Or I can plug in g of 4 here, right? 4 times 4 is 16 plus 3 is 19. All right, and then it says f of 4 plus g of 4. Well, that's just 17 plus 19, which is, of course, 36. It does work. So there's two ways to do it. Some students like plugging the 4's in here first because maybe you do less algebra, but either way you should get the same answer. Okay, so what happens here when we get more complicated functions? Okay, for this one here, I'm going to look at h of g of 3t. So we're taking h of g, which means I'm going to rewrite h, but every time I have a t, I'm actually going to plug in the function of g. So there's my 3t plus 1, right? See, that's h of t. But everywhere the t appears, I'm going to plug in g because it's h of g of t. And I'll get to the 3t in a minute here. So I'm just writing h of g. So I write down my h function. It's 3 times whatever the variable is, t. But wherever t occurs, I'm going to write g. So now I'm going to plug in g right there. Don't even think too much about it. Don't let it confuse you. Hope we haven't already, but I'm going to take that, and wherever t appears, I'm going to plug in g of t, because you're really taking h of g, okay? So there's h of g of t. Everyone got it? All right. I could simplify this if I want to. FOIL this out. 3 times minus 3t is minus 9t. 3 times 1 is 3. All right. And this 1 just sits out there on its own. So if I really want to, I could simplify further and go minus 9t plus 4. That is h of g of t. Hello. Can't grab my thing here. But it doesn't say h of g of t. It says h of g of 3t. Whenever we simplify a function like this, we know that we're going to evaluate it at some value. Now, instead of giving us a nice number like 2 or 4 or whatever, they've given us 3t. So I go back to wherever t appears, and I plug in a 3t. So instead of t, I put in a 3t there, plus 4. What's minus 9 times 3t? Well, it's minus 27t plus 4. I don't get a final numerical answer. I have an expression, minus 27t plus 4. That's how those work. I hope that makes sense to you. Okay, this last one I think is a little bit simpler. All right, we've got f minus g, which is the same as f of something minus g of something, and I'll leave that out because it's a composite function again, it's x squared. But we know f of x is going to be x minus 4. Then it says minus g of x, which is minus the function 3x minus 1. Notice I put f over this parentheses, g here. Now if I simplify, I'm going to get x minus 4 minus 3x, and a minus here is a plus 1. So I could simplify further if I wanted to. X minus 3x gives me a minus 2x, right? Because there's really a 1 there. Minus 3 plus 1 gives me a minus 2x. A minus 4 and a plus 1 gives me a minus 3. So there's f minus g of x. But this time they want me to evaluate it at x squared. So I just go back, and wherever I see an x, I replace it with an x squared. So minus 2, I plug in x squared minus 3. So my final answer is minus 2x squared minus 3. Okay, I hope that helps you understand that. There you go.